All right, so for the function f of x, you have to find f of a plus h minus f of a over h. So when you're doing this, okay, what you have a couple options. What I like to do, so I don't have to write out my work a bunch of different times, is I'll find f of a plus h first, okay, and then here's my work for it here. So f of a plus h just means you're plugging in a plus h for x. Remember, you have to write it out twice in FOIL, then you distribute the 4, okay, and then once you do that, you should have a whole expression here, okay, which you can plug into the top. Okay, now, when you do minus f of a is just going to be this expression. I'll write it here. F of a is just 4a squared minus 4. So when you plug that in, if you have a minus, remember you have to distribute it. Okay? If you don't distribute it, then you won't get the correct cancellation. And then once you have simplified, combined all your like terms, you should get to a point where you can either divide by h or you can factor out an h. So I wrote down the two different possibilities. So some of you might divide each one by h, some of you might factor out the h. This is the one that we talked about, is where you factor it out. Okay, but you have to make sure that you show one of those steps, and then your final answer is the 8a plus 4h. Okay, questions for me on number 1? So number 1 is on the no calculator section. So you did a good job. So this is on the no calculator section, so this will be on the part for tomorrow, okay? All right. This next one is where you have the function, okay, and then the height of the soccer ball in feet is given by the function, okay, where x is the horizontal distance. You have to find h of 10 and h of 66.3. Okay, so I feel like that went well. Remember that this square root, okay, this square root here was only over the 3, and I know that was, some of you asked me about that, so I wanted to point it out. Okay, so then when you plug in the 10, you're going to round to the nearest hundredth. 14.71 is what you should get for h of 10, and that's measured in feet. And then when you plug in the 66.3, you get 0.00878, and that's going to round, when you're rounding to the nearest hundredth, 0.01 feet. Question for me on A? Question for me on part A, plugging it in, finding the answer is good? Mm-hmm.
So this is just something for like a
yeah.
Mm-hmm. Down to the nearest hundred.
Yeah, and the directions will tell you that on your test. They'll have you.
Okay, that's what I was wondering.
Yeah, yes.
So I thought it was just like a consistent thing.
Yes, yes. Okay, so when they're asking you to explain and complain in a complete sentence, what it means is you have to include details about the input and the output. Okay, so include details about the input and the output. So what I did is I went back to my equation and I went back to my story problem and I said, okay, the h is the height. So my output is going to be the height, and that's measured in feet. It says the height h of the soccer ball in feet. And then it says x is the horizontal distance, so that's also going to be in feet. Okay, so the horizontal distance is how far it travels left to right, and then the height is how far it is up or down, or up in this case. So what you could say is that h of 10 represents when the ball has traveled 10 feet horizontally, the height of the ball is 14.71 feet. Okay, so you have to say, what does the input represent? That's the 10 feet horizontally. Okay, and then the height of the ball is the 41.7 feet. So you have to include, I'm sorry about that. You have to include details about the input and the output. So we're including the units, and then we're including what it is. The units are the feet, and then you have the horizontal distance and the height. All of those are weaved in. Okay, and you can feel free to write down what I have written down. Okay, and then for H of 66.3, that represents the height of the soccer ball, which is 0.01 feet when the ball has traveled 66.3 feet. Okay, and that's horizontally. And really, could you have said this exactly like this? Yes. I'm just showing you multiple ways that you could write this and still get full credit. So make sure you're mentioning the height, how many feet that is, okay, and then when the ball has traveled to 66.3 feet, that's going to be horizontally. All right, now, A and B go with this problem. On your test, when you're doing this, sometimes things are going to be measured in different units. So in order to prepare you for that, I gave you the next few questions. So in terms of this story problem, it's not going to make much sense. Okay, the ones that you're going to see on your test will make sense in context. I just wanted to give you more practice on that, okay? So I said, let's say h of x is measured in thousands of feet. Okay, write your answer and explain what they mean. So h of 10 and h of 66.3 are always going to stay the same. Okay, those are always going to stay the same. And you don't have to write every single thing down that I wrote here. You can just add little adjustments. The main thing is I want you to understand that the input and the output, the numbers stay the same here, right? H of 10 is 14.71, the H of 66.3 is 0.00878. The reason why I wrote them out to the thousands place is because I'm going to be multiplying them by what? Thousands, the thousand, because it's thousands of feet. So this time, h of 10 represents if the ball has traveled 10 feet horizontally, then the height would be 14,708 feet. So like I said, I modified this question to give you practice on how to write this, okay, which is why this doesn't make sense in terms of the problem. So if they tell you it's measured in thousands, you multiply by 1,000. This is exactly like what we talked about in our Choose 7 notes. And then you would take the output, multiply that by 1,000. So if the output is measured in thousands, when you are explaining, that's when you're going to say what it is. This would be the output, and then you would explain it in your answer. So I know that one was kind of tricky for some of us. What questions do you guys have? What can we talk about to clarify some things?
It's going to be on Fridays, right?
No, because there's no calculator by it. There is? Oh, just not on mine. Okay, yes, thank you. Yes, that'll be on the calculator, I think. But knowing how to write this is going to tie in with some stuff that's on the no calculator portion, but that's on the last question. So it's similar to that. Yeah. Yes. Yes, I wouldn't have you do this kind of calculation. All right, and then so D is very similar. Again, it's just the same answers, the same input, the same output. But if your X is measured in 10,000s of feet, you just take the input and you multiply it by 10,000 when you're explaining. So the only time that those are going to be different is when you're explaining. to change is the explanation part. So now you would say h of 10 represents when the ball has traveled 100,000 feet horizontally, the height of the ball is 14,708 feet. Your explanation is where you multiply. Are we clear on that? I know I'm repeating myself over and over again.
Oh, okay.
Abby, that's coming to you. Okay, and then, so for this one, your output, that's what gets multiplied, okay? So this represents when the ball's at a height of 8.8 feet, then the ball has traveled the 663,000 feet horizontally. All right, so I just want you to be prepared. If they say X is measured in hundreds, thousands, 10,000s, know what to multiply by, and that's only for your explanation. This is your answer, this is your explanation, okay? And then if it's the output, you just multiply that by whatever it's measured by. Okay? All right. And then for number 3, find the domain of the function, write your solution in interval notation. Okay, we're going to do that one together. So when you are doing the domain, remember, domain's going to be a big part of this. You have to make sure if there's anything underneath the radical, you take that and it has to be positive. So it's greater than or equal to 0. Is this linear or nonlinear? Nonlinear, because it's quadratic, right? Okay? If it is nonlinear, you are going to have to factor this. So you have 3x and x, what multiplies to negative 2, but adds to negative 1, plus 2, minus 1. And then remember, from here, you are going to get your key values. So if 3x plus 2 equals 0, your key value is negative 2/3. For x minus 1 equals 0, x would be 1. Okay, and then from there, this is where you have to do your table. So you have negative 2/3. Okay, the negative 2/3 and then the 1. And then you have negative infinity to negative 2/3. Is this going to be a soft bracket or a hard bracket? Why? Good. So you have the greater than or equal to, and then are you going to look for the positive cases or the negative cases? Positive. Why? Because it has to be greater than or equal to 0. So the soft bracket's only going to go with the infinity, okay? And then remember how you can make the table. You're going to put your factors here. So your two factors are 3x plus 2 and x minus 1. And then you're just going to do test points. So pick a value that's in between negative infinity and negative 2/3. Negative 1. So this would be negative 3 plus 2. That's a negative. Negative 1 minus 1 is a negative, so that will be a positive. Okay, between negative 2/3 and 1, 0 would be the easiest one. So that would be 2 and negative, so that would be a negative. And really, if this one is positive, what should happen? They always alternate. So this one should be positive. So if you plugged in 2, you'd have 8, and then 1. Yay. Okay, so then if you're writing this in interval notation, what do you use to connect those two? A union. Great. So negative infinity to negative 2/3, union 1 to infinity. This thing is driving me nuts. So this is. Okay. All right, and then the piecewise function, it looked like you guys did a nice job with this. You do have to make a table to support your graph. You could also make a few tables. It just depends on what you'd like to do. So sometimes I'll write on the side, okay, if this is negative, it should be going down from left to right. This is going to be a straight line. This is going to be a parabola. So make sure that you connected this with a curve and not with a straight line. How do you know when you have a closed circle versus an open circle?
How did you know like the straight line was a parabola?
Because this is linear, so because it's just the x. If it's just the number, it'll be a horizontal, and then x squared, that'll be your parabola. So those are your functions, okay? And like I said, I split this up into 3 tables. You can make 3 separate tables. Okay, so one for the first one. If it's x is less than or equal to -1, okay, you do include the -1, you have a closed circle, and then you can plug in like -2. Okay, what happens when you have a negative in front of -2? It becomes positive, so 2 minus 2 is 0. Okay, so you can plug those in, you should have a straight line there. You could also use the slope. And then even if you have an open circle, you have to plug in -1 and you have to plug in 2. Because if you don't, you're going to miss the infinite amount of points that are in between them. So will you guys check that for this one? That you have them at the correct spaces? And then for the quadratic, so you have the 2, plug in 2, you get 4. You plug in 3, what do you get? 9, okay? So that's how you're creating your different tables. Okay, and again, if you make 3 tables, that's perfectly fine. In fact, sometimes I think that's a little bit easier, okay? Okay, so number 3 and number 4 are both on the no calculator portion. So both of these will be on your portion for tomorrow, okay? So if there's not a little calculator on them, if there's not a little calculator on it, these will be on the no calculator portion, and so that part will be on tomorrow's test. Okay? Okay, so for 5, you are graphing on your graphing calculator. Okay, what I did is I drew a little graph of what it was. So this is on your calculator portion, so this will be on Fridays. So if you want to write like part 2 next to it, that's fine. So for that one, you have to graph and then find all the local maximum and minimum values and find the value at which x occurs. And then you have to specify whether it's a min or max. So, do you see how I said do not write your answer to the coordinate point? So the way they want you to write the answers when they say this, to find all the values and the value of x at which they occur, you're going to say y at x equals this. Okay, so your minimum is 0 at x equals -2. When this was -2.00, like mine was rounded. Okay, if yours was an exact number, you could put -2. Alright, that would be fine. And then this was 0 at x equals, so again, like mine was rounded to 1.00. And then your max was 5.06 at x equals -0.50. And then anytime you do the intervals, those should be hard brackets, and those are the x values. So hard brackets and then the x values. Okay, remember that when you are trying to find your window here, you can always go back to the standard window and then you can adjust your y's and your x's. You could do your zoom fit. And then do you guys remember how to find the minimums and maximums on your graphing calculator? Second calc. And then if it's a min, you'll hit minimum. If it's a maximum, you'll hit maximum. They'll always ask you to the left, to the right. Take your guess. Okay, what questions? I know.
Are you recording this?
This part? Okay, so should we graph that on our calculator? Okay, so do you have yours?
Yeah.
Yeah. All right, so we'll plug it in and then we'll practice finding them. Not a problem. And if you feel like you know this part, I'm fine if you do one of the questions from your bell work, okay? Just stay focused on your test stuff. You can study some other things, or you can look and see what questions you have. All right, so we're going to be graphing this. So it's x to the 4th plus 2x cubed minus 3x squared minus 4x plus 4. Okay, and then, so I'm going to go to zoom and then Z standard. So that's my 10 by 10 window. Okay, so once I have that, I like drawing the sketch here because it's easier for me to look at that and see where it's increasing and decreasing. So I'm going to go to second calc, and then the first thing I have is a minimum, okay? So it's asking me left bound. So I'm going to tell it where I want it to look for the minimum value. So I want it to look for the minimum value in between those two. You can make a guess, and then this is your minimum. So remember I told you that I rounded mine to 2, that's why I put 2.00. It's because here you have the negative 0.19. Focus up here, or you can do your bell work. Those are your options. And then when you have 2.6 and you have that e to the negative 11, what does that round to? 0. So you can just put 0. It's fine. Anytime you have a number that large, it just is going to be 0. Okay? All right, and then if you go to second calc and then find the maximum. Yes, I just did them in order, so I am going to do the other minimum too. And that's asking me to guess. Okay, so rounded, this would be negative 0.50 and then 5.06. And then there's another minimum, so I'm going to do that again. And then like I said, I like to draw the little things so I can see what it is. And right bound, my guess. Okay, and then so that rounded to 1.00, and then that was 0. Again, some of your calculators might have written that as 1. If yours just says 1, that's okay. Okay? All right, and then, so the minimum is the y coordinate at x. So this is 0 at this x value, that's the minimum. The other minimum is 0, so it's the y, okay, at your x value. Then the max, again, is the y at this x value. And this one just happened to have 2 minimums and a max. You could have 2 maxes and a min. You could have 1 min and 1 max. Okay, so that's okay too. Now the increasing, those are always your x values. So I highlighted in pink where it was decreasing, and I highlighted in yellow where it was increasing. So from here to here, it's increasing. Okay, so increasing from negative 2.00 to negative 0.50, and at 1.00 to infinity. The decreasing starts at negative infinity and goes to negative 2. Okay, and then it starts at negative 0.50 and goes to 1. So I might write this down that you have the hard brackets, that it's the x values, and then I would pick some out to do. Again, this is the one on Friday. For the increasing and decreasing intervals, they'll always be hard brackets unless they're infinity or negative infinity. They'll always be increasing up to that point. All right, so we're going to talk about the average rate of change, and I feel like part A went very well, and part B we're going to have to do out together. Okay, so for part A, you're plugging in 0 and 6 into your equation and finding the y values. Once you do that, you have points. This is 0, 4. When you plug in 6, you get 22. Okay, notice that on That one you don't have a calculator, so that will be on tomorrow's. Okay? Any questions for me on this part? On part A. Okay, because we're going to go over part B in detail. Okay? And I can put that back up if you need it. Okay, so for part B, the first part is the same. Okay, you have 1, you're going to plug in 1 into your function. So this is 4 plus 1/2, 1 squared. Follow your order of operations. Okay, 1 to the second is 1, 1 times 1/2 is 1/2, 1/2 plus 4, 4.5, 4.5. Okay, now I know the second one kind of threw some of us off. If you plug in A, all you have is 4 plus 1/2 A squared, like this. Okay, so now when you're doing the slope, same thing that you did before. Okay, it's always f of b minus f of a over b minus a. Okay, that's what you're doing. Same thing as y2 minus y1 over x2 minus x1. So if you plug these in, okay, you can think of this as, think of it as your x1, y1, your x2, y2, because a lot of you have your slope formula memorized, right? This is the same exact thing. So if you do 4 plus 1/2 a squared minus, because it's only one term, you don't have to worry about the distribution. And then on the bottom, you have a minus 1. Now all we have to do is simplify. What's 4 minus 4.5? Negative half. So it's 1/2 a squared minus 1/2 over a minus 1. What can I factor out of the top? 1/2. So if you factor that out, you have a squared minus 1 over a minus 1. Guess what you can do with a squared minus 1? So here we factored out the GCF, right? So we factored the GCF here, the 1/2. Now what is this? How do you factor this guy? A squared minus 1, what is it? Yes, a minus 1 times a plus 1. It's the difference of two squares. So a times a is a squared. The middle cancels out. Negative 1 times 1 is negative 1. Okay, how does that lead me to my next step? Yeah, what's going to cancel? Yep. So those cancel. You're left with 1/2 times a plus 1. So 1/2 a plus 1/2. That's your final answer. Okay, so when you're doing this, you have to simplify and you have to factor. Okay, you have to simplify, you have to factor. That is in lesson 2.4, so if you guys need some practice with that, like I said, this is in 2.4. If you want to go back to that homework and do one that's similar, you can absolutely do that. All right, 7, the next one is on the calculator portion, and so that one will be on Fridays. So the one thing you have to remember is that you're going to label your units. Okay, so if it says what was the man's average speed, which is the rate, between 108 seconds and 335 seconds. So what I did is I just highlighted the two rows that we're going to use, and you use your slope formula. This is your y2, your y1, so you do y2 minus y1 over x2 minus x1. Okay, and then look, you are given the units here. The distance is in meters, right? The time is in seconds. So that's going to be meters per second. You could write it like this, or you can write it like this. Okay? And then again, it says round the answer to 2 decimal places, so you just have to follow your rounding rules. 4 and below stays the same, 5 and up, round it up. Okay? Alright, ready for the next one? I feel like these went well, so let's check those. For 8A, you should have 36. For B, you should have negative 3,130. So remember, each of these are 2 steps. Okay, step 1, work your way on the inside. Oh, technically that should have another parenthesis on it. It'll look like that. Okay? Well, they would have the extra one like this, okay? So g of negative 1, and then look, this is on the no calculator section. So you have to follow your order of operations. Negative 1 to the 5th is negative 1. Negative 1 minus 5 is negative 6. Then you can plug this in. F of negative 6 is 2 times negative 6 squared plus 5 times negative 6 minus 6. So if you're following your order of operations, negative 6 squared is 36. 36 times 2 is 72. And then I did this together. 72 minus 36 is 36. Okay, and then for B, g of 0 is what you would do first. When you plug in 0, you get negative 5. So then you're going to do g of negative 5. And then negative 5 to the 5th is kind of a lot. So I know what negative 5 squared is, right? What's negative 5 to the second power? 25. Do you guys know 25 times 25 is 625? Okay, if not, you could multiply that out. So I knew that was 25, so I did 625 times negative 5. That's how I got my final answer. Okay, and then so that's on the one tomorrow, and then let's go to the last page. And this is, we're definitely going to do that out. I don't think so, but I can check. And then, yeah, but I should have one posted though in the Google Classrooms. All right, so I told you guys yesterday, remember that got cut off, and we have to do that. All right, so you have to find f of g, g of f of f, g of g, and the domains, okay, when you're given these values for f of x and g of x. So for f of g, you're plugging g of x into f of x. Okay, so your g of x into f of x is going to be 1 over, and then instead of x minus 1, it's going to be the square root of 2x minus 1 minus 1. Okay, you don't have to rationalize the denominator. Okay, you can keep it just like this. Now, when you're doing the domain, sometimes you're going to have to set up 2 separate things here. So one thing we have is the square root. Okay, if you have an even root, yes, whatever's underneath the radicand can't be negative. It has to be greater than or equal to 0. So for the square root of 2x minus 1, you would set 2x minus 1 is greater than or equal to 0. What other case do we have here? The fraction. What can't you have with a fraction? Denominator can't equal 0 with the fraction. So what you do is you take the entire denominator, so this can't happen, and you also have to have the entire denominator can't be equal to 0. So we set it equal to 0 and we solve. Okay, this is just a 2-step inequality, so 2x is greater than or equal to 1, x is greater than or equal to 1/2. At the same time, we have to solve this and combine them together. So we would add 1 to both sides. How do you undo a square root?
Square.
Good. So you're going to square both sides. 1 squared is 1. 2x minus 1 equals 1. So 2x equals 2. Divide by 2. X can't be 1. Okay? A good way to write this in interval notation is to think of this as a number line. So you have 1/2, you have 1. you know that x has to be greater than or equal to 1/2, but it also can't include 1. So you have to say this as in interval notation. So if you have a closed circle, that means you have a hard bracket, so it's 1/2. It goes to 1. Because it can't equal 1, it's a soft bracket. And then in union with 1 to positive infinity. So this is your domain. All right, and then for your g of f, oh, sorry, I didn't mean to. It's 1/2. Thanks. It's positive. So 1/2 to 1 in union with 1 to infinity. Okay, for g of x, when you plug this in and you get 2 times 1 over x minus 1, okay, what you're going to have to do is multiply the fraction. When you're multiplying a whole number by a fraction, remember, you only multiply the numerator. Okay, now if you have a square root, you want whatever's underneath to be one term. So we want to get a common denominator. So we're going to multiply the top and the bottom of this by x minus 1 so that we have a common denominator. Okay? So that means we have the square root of 2 over x minus 1, and then this would be minus x plus 1. I would put the plus in between. I distributed it at the same time. If you have the -1, I did -1 times x to get negative x, -1 times -1 to get plus 1, and now you can combine those all together. Okay, so 2 plus 1 is 3, so you'll have 3 minus x on top, x minus 1 in the denominator, and that will be your g of f. Okay, the reason why you want this to be all one thing is because when you get to do the domain, you are going to take whatever is underneath the radical, because it's an even root, and you have to take this and you have to set it greater than or equal to 0. Is this linear or nonlinear? If you have the x in the denominator, it is nonlinear. Okay? And so this means you have to do your chart. Okay? We actually did an example just like this in 1.7, if you want to go back and look at that. Okay? And then when you're doing the table, you don't have to factor. These are your factors. Okay? So your key values are what makes the top 0. So if you have 3 minus x equals 0, 3 would equal x. This is one of your key values. If you had x minus 1 equals 0, 1 is your other key value. And then remember, we can put this on our number line. What comes first, the 1 or the 3 on your number line? 1. So you have to pay attention to that. Okay, so again, this is an equal to, so your intervals are -infinity to 1, okay, and then for 1, can you also have a fraction? So if you have x minus 1, is that going to be a hard bracket or a soft bracket? It has to be a soft bracket. So the denominator can't be 0, so x can't be 1. Okay, so then this has to be a soft bracket here. 3 is a hard bracket because it's not in the denominator. And again, the 1 is a soft bracket only because if it was 1, the denominator would be 0. And now you can do your chart. And then I'm just going to show you, I'm going to put the factors over here, okay? So your first factor is 3 minus x. Your second factor is x minus 1. Same thing that we did on the front page. So if I pick a number between -infinity and 1, I would choose 0. 3 minus 0 is 3, so that's positive. 3 minus 1 is 2, so that's positive. That's negative. Thanks. Okay, 0 minus 1 is negative 1, and then a positive times divided by a negative is a negative. Okay? Alright, so what's a good thing to choose for between 1 and 3? 2. So 3 minus 2 is 1. Okay, and then 2 minus 1 is 1, so those are going to be positive. And then let's choose 4, so this would be negative. 4 minus 1 is positive. Okay, so then your domain is going to be this interval. Okay, so your domain is going to be 1, 2, 3. You only have to do the chart if it's non-linear, okay? This is linear, we didn't have to do the chart. Don't throw things. Don't throw things. Okay, and then the next one is your f of f. Okay, so your f of f means you're plugging f of x into f of x. So you have 1 over x minus 1 minus 1. This is a complex fraction. Okay, this is something that we did in chapter 1. So again, you have to make this into one simplified fraction. So we're going to multiply the top and the bottom by x minus 1. Okay, and then if you want, you can think of this as over 1, right? And you can distribute the negative. So this is going to be 1 minus 1x plus 1 all over x minus 1. And then this would be 2 minus x, or negative x plus 2. Now, when you have division, this is your division symbol. Okay, this means you can do 1 times the reciprocal. The reciprocal is x minus 1 over 2 minus x. So you're going to flip that. Okay, and then this is going to be your final simplified answer. So x minus 1 over 2 minus x. This is your f of f. Okay, now, what you have to be careful of here is when you have fractions, okay, and fractions within fractions, you have to make sure you check at the end and at the beginning. So at the end, what could x not be? 2. Okay, so x can't be 2. Now we also need to check at the beginning. What's something x couldn't be in this denominator? Okay, so from this denominator, x can't be 1. Do we have another denominator? Really, you have this whole thing here, right? You have the 1 over x minus 1 minus 1 equals 0. Okay, but if you do that out, and you can, you multiply each side by x minus 1, look what you end up getting. 2. So x can't be 2. So you can't have x be 1, you can't have x be 2, and then we're just going to write that in interval notation. Okay, so your domain is going to be, again, feel free to think of this as your number line. Here's your 1, here's your 2. So it goes from negative infinity to 1, open parenthesis, because you'll have an open circle, in union with 1 to 2, in union with 2 to infinity. That's going to be your domain. Okay, so you have 3 different intervals you need to connect together. Okay, and then the last one, the g of g. When you plug that in, you have the square root of 2 times 2x minus 1 minus 1. Okay, you don't have to simplify that. The only time you have to simplify the radical is if you have just a radical within a radical, nothing multiplied to it, nothing subtracted. Okay, so that's all you have to do for that one. And then your domain. How many radicals do you have? 2. So how many inequalities are you going to have to set up? 2. So you have 2x minus 1 is greater than or equal to 0. And then underneath the other radical is 2 times 2x minus 1 is greater than or equal to 0. So we just have to solve each of these. Okay, so I know you guys are good at solving ones like this. With this one, you would add the 1 over. You would divide by 2. Okay, and then what do you do when you get here? Square it. So you have 2x minus 1 is greater than or equal to 1/4. Okay, so then you're going to add 1. Do you guys know what that is as an improper fraction? Yeah, 5/4. And then when you divide by 2, that's the same thing as multiplying by what? Yeah, so it's x is greater than or equal to 5/4 times 1/2, which is 5/8. So when you have the two inequalities, you just want to see where they overlap each other. So what's larger, 1/2 or 5/8? 5/8, right? Because what's half of 8? 4. So if you had greater than 1/2 and greater than 5/8, the part where they overlap is here. So your domain is just 5/8 to infinity. Okay. All right, and then for number 10, I'm going to show you what this is your inverse. You have to write this in inverse notation. Okay, you can have 7x plus 10 divided by 1 minus 3x, or you can have negative 7x minus 10 divided by 3x minus 1. It just depends on what side you move the x to. Okay, so when you're finding the inverse, you switch the x and y. So x equals y minus 10 over 3y plus 7. What's always your first step? Multiply by the denominator, right? So if you multiply by the denominator, 3y plus 7, make sure that you distribute. So you have 3xy plus 7x. And then this is where I got questions yesterday. You want to move all the y terms to one side so you can subtract y. Okay, and then if you move the y terms here, you're going to move the x terms here. Now, once you have the y terms on one side, you have to factor them. So you have to factor out the y. And then your last step is going to be to divide. Okay, so that's where you would get the f inverse equals negative 7x minus 10 over 3x minus 1. Okay? If you move the x's to the other side, that's when you would get this. And that's fine too. All right, and then the last one is also the no calculator. So everything on the back page will be on the no calculator. This is one where A is measured in thousands of dollars, okay, for X years, and you are given a function. When you are finding the inverse, remember that your input and your output are going to switch. Okay, so when you have a story problem, do not switch the A and the X. All you have to do is solve for X. Okay, so all you have to do is solve for X in the equation. Do not switch them with the story problem. Okay, so if you solve for x, you're going to subtract 100, divide by 5. You could leave it like this. If you did a minus 100 divided by 5, that's fine. If you split them up, that's fine too. Either one of those are correct, okay? Now, I want you to pay attention to this. When you're finding the A inverse and you get 13, this is how you're going to leave this. And then your explanation is where you apply if it's measured in thousands or if it's measured in hundreds. Okay? You have to make sure you put it in context. So this is after 13 years, the account will contain 165,000. So the original, years was the input, dollars was the output. When you do the inverse, they switch. So I always write out my input and my output for the original, and then I switch it for the inverse. Okay? I will be hanging around after school, so if you guys want to come and ask me any questions, you can. Okay, I'll be hanging out in my room, okay?